In the next few lessons, we will be learning a very, very important algebra skill, factoring. So we're going to start with the basics called the greatest common factor. We call it the GCF. Let's just make sure we all know what a factor is. It says in general, if A, B, and C are natural numbers, and A times B equals C, then A and B are factors of C, meaning things you multiply together. So 30 has factors. 5 times 6 can be 30. 30 could be 3 times 10. 30 could be, 2 times 15. 30 can be lots of things. It has lots of different factors. But we also talk about prime factors, meaning break down those numbers to the smallest they can be. Right? And so we could have 2 times 3, which is 6, times 5. So 2, 3, and 5 are the prime factors of 30. But you can also see that 10 is a factor of 30, 15 is a factor of 30, because it divides 30 evenly with no remainder. And so that's why we would call factors or also divisors. In general, when we're factoring, we're really dividing. We're finding what multiplies to get back where we started from. So our goal today is to find the greatest common factor of different terms. So let's look. If I wanted to find the greatest common factor of those three monomials, well, first of all, you look at the numbers and you ask yourself, what is the largest number that divides all of them? 2. So GCF is 2, meaning they are all divisible by 2. There's not a bigger number that divides all of them. Then we look at the letters. Well, they all have an x in common, and so x is a common factor. The greatest common factor would be the smallest exponent, because they only have one x in common. Then we're going to look at, do they all have a y? Yes, they do. So y is also a common factor, and we look and we choose the smallest exponent because, again, they have a y squared in common. When finding the GCF of numbers, we are looking for the largest number that divides all the numbers without a remainder. Looking at the numbers, we want the largest. When finding the Gcf of variables, we are looking for the smallest exponent on the letter that they have in common. If you go back up to here, that's exactly what we did. So how are we going to factor completely? Look at number 1. The first thing we're going to do is we're going to look at the numbers and say, all right, what are those both divisible by? This is why it's important to know your multiplication tables. Well, they're not divisible by 2 because they're not even. They are divisible by 3. Is there something bigger? Yes, 9. So we have 9 as a common factor. Then we look at the letters. Do they have anything in common? No, they do not. So we're dividing both of these by 9. So I'm going to put a parenthesis. So 18 divided by 9 is 2, and then that would leave you an x. So we are dividing 18x by 9. We're dividing by that monomial again. Now we're dividing negative 45 by 9, so that's negative 5, and that would leave you a y. So we're not just finding the GCF, we're factoring completely. Meaning you could check your answer, although it's not 100% check, if you multiplied your answer, do you go back to the problem? Yes, you do. Let's look at number 2. So the first thing we want to do is we want to look at the numbers, and we want to find the largest number that divides 24 and 32. So some of you might say 4. Well, that is a common factor. Something bigger than 4. 8. So I know 8 goes into 24 and 32. Then I want to look at the letters. Well, they have an x in common, so x is a common factor, and I want to take it to the smallest exponent. And then I see they both have a y, and I want to use that to the smallest exponent. So that is what I'm dividing by. So I want to divide each of these by 8x y squared. So 8 goes into 24 3 times. X cubed divided by x is x squared, and then those would reduce. Then 32 divided by 8 is positive 4. The x is reduced to 1, and that would leave me y squared. So again, factoring is dividing. Let's look at the next the next two examples. So as I look at number 3, and I look at these numbers, I have a negative 28, a positive 14, and a negative 7. Now you should know those three numbers are all divisible by 7, and we could say they're divisible by positive 7 or negative 7. Usually when we have a negative in the beginning, we like to take it out, meaning factor it out, divide it out. So I'm going to divide out by a negative 7 instead of a positive 7. Then, do they all have an x? Yes, they do. Smallest exponent is 1. Do they all have a y? Yes, they do. The smallest exponent is a 2. So that's my GCF. So I'm dividing each one of these terms by a negative 7xy squared. So let's divide. A negative 28 divided by a negative 7 is a positive 4. Look at the x's. That would divide out to an x, and the y's would leave me 1y. And the next one, a positive 14 divided by negative 7 would be negative 2. Again, looking at the x's, that would leave me an x, and that would leave me y squared. On the next one, negative 7 divided by negative 7 is positive 1. X goes into x one time. Y squared goes into y squared one time. So we just have plus 1. If you don't put that 1 there, it's wrong. When we divide, you get 1. You don't get 0. So that 1 has to go there. And again, you could check, but I'm telling you again, it's not a 100% guarantee check. If you multiply this back out, you should get back out what you started out with. Let's look at the next one. 12, 24, 8, and 20. Are they all 4 divisible by something? Well, I know they're even, so they're divisible by 2. What's the next number? 4? Does 4 divide all of them? What about 6? No, 6 doesn't go into 8, 6 doesn't go into 20. So I think 4 is the biggest number. Now, do they all have an x? Yes, they do, to the first power. Do they all have a y? Yes, they do, to the first power. So, since I have 4 things, I'm going to end up with 4 things in my parentheses. Same thing on number 3. I started out with 3 terms, so I end up with 3 terms inside my parenthesis. So on number 4, I should also end up with 4 things in my parentheses. So I'm going to divide both of these by 4xy. So 4 goes into 12 3 times. The x's reduced to x squared, and y goes into y 1 time. The next one we divide. I have negative 6 x y. On the next one, negative 2, the x's divide out, and I'm left with y squared. And on the next one, I have negative 5 x squared y squared. Final answer. So greatest common factor, we want the largest number, and then on the variables, if they are all in common, you want to take that variable to the smallest exponent.